Hi, welcome to our first video for 4.5 problems in 3D. In this lesson, we're basically going to take everything we learned about solving problems in 2D and apply them in a 3D setting. So this is definitely appropriate because a lot of problems in real life arise in three-dimensional settings. So I've included some tips in here for being successful in this section. So I find that this section can be a little bit challenging because you need to read the problems and interpret what is being asked and then draw a good diagram. So here's a few pointers that I have that maybe might help you along the way. So always read out the questions several times and then attempt to draw a good labeled diagram. Make sure you label everything appropriately. That way you can look at it and not make any errors along the way. I like to say this is half the battle. A good diagram, once you've done that, then it's just a little bit of trigonometry and you can solve whatever you're looking for. So once your diagrams are established, determine what you're looking for in the question. So maybe go back, reread it, and then find what information is needed or missing to solve what you're looking for. Okay, so this basically means come up with a plan. Okay, so determine a plan to find the said information. When working with right angle triangles, use SOHCAHTOA and Pythagorean's theorem. And if you have oblique triangles, then just use sine law or cosine law. Lastly, just write a final statement, include your units. Okay, let's get started with this first example. It says use primary trig ratios to solve a problem in 3 dimensions. A radio antenna lies due north of Sam's house. So here's Sam's house. Due north is the radio antenna. Sam walks to Elena's house, a distance of 1,200 meters, 50 degrees east of north. So if you notice, north is kind of orientated this way. So 50 degrees east of north would be along this line right here, all the way to Elena's house. You can see we have everything labeled nicely so far. Then it says from Elena's house, the antenna appears due west. So if north is this way, west is this way. Okay, so due west is the antenna with an angle of elevation of 12 degrees. So if you're standing at Elena's house, you would have to look up at an angle of 12 degrees. So the angle of elevation is always measured from the horizontal. So it says determine the height of the antenna to the nearest tenth of a meter. So if you were standing at Elena's house and you look to the very top of the antenna, the angle that you make with the ground would be 12 degrees. The nice thing with this question is that the locations of the houses, they're like south of the antenna and then east of the antenna. So we know we have a nice 90-degree right in here at the vertice. Also, the antennas always stand straight up, so they also make 90 degrees with the ground. Okay, so notice they've tried to draw like a 3D problem on like a 2D page. So it is a little bit challenging, but if you can, try to look at it spatially. So if you're looking straight downwards, you're going to see this nice right angle triangle. It means we can use SOHCAHTOA. If you're standing on the ground and you're looking this way, you can see this nice triangle right here, also 90 degrees. And if you're standing at Elena's house looking this way, you could see this nice triangle that could be formed as well. Okay, so we're looking for the height of the antenna. So we kind of need to come up with a plan for this. So sometimes I just draw additional triangles to help me along the way. So, all right, so I think in order to find the height of this antenna, I have the angle here. It'd be pretty nice if I had one of the side lengths on here. So in order to get this height, when I have the angle, if I knew this distance here, that would actually really help me out because I could just use SOHCAHTOA and I could find the opposite side. So is it possible for me to obtain this length? Well, I think it is because if we were to look straight down at this triangle here, we have the angle 50, we have this length here. We would just need to find that length and then we would be able to determine whatever we need. So I'm going to draw another triangle here. It's going to basically be the one from Sam's house to Elena's house. Okay, so there's the 50 here. There's Elena's house. Here's Sam's house. And I'm going to call this distance, here we'll label this A for the antenna. So from A to E, I'm going to call it D. Okay, that's just the distance from Elena's house to the antenna. Okay, so I'm going to write that down here. We'll say let D be the distance from Elena's house to the antenna. I'll say the base of the antenna. Right, antenna. Okay. And we also have right angles in the triangle right here, right? Okay, this is pretty easy to solve. I can find that distance D. So D is kind of right along here on that diagram. Okay. All right, so solving this is actually quite simple. It's a right angle triangle. We can just use SOHCAHTOA. So I'm going to write out sine of 50 because sine of 50 is going to equal the opposite over the hypotenuse. I forgot to write this down. This was 1200 meters. This length here, right? You can see that up here. Okay, so sine of 50 is going to equal opposite over hypotenuse, so it'll equal D over 1200. We can just rearrange and solve for D. Okay, plug it in our calculator. 1200 times sine of 50, 919. I just leave a couple decimal places because we're going to be using that to make another calculation. Okay, so this is actually really nice. I got this base here. I'm now looking for the height. So I'm going to draw that next triangle. So there's Elena's house. So what I'm actually drawing it the side view. Okay, so if you were standing on the ground looking this way towards the north, you could see this right angle triangle that's formed with Elena's house and the antenna. So this is the antenna here, and we're looking for the height. I'm going to call it H. Okay, this length down here, we just calculated that when we found D from A to E. So 919 and 25. Okay, so I can easily find H. And I do need that angle of elevation that was 12. Okay, so just applying SOHCAHTOA again, I could say this time this angle has H as the opposite and the given information is the adjacent, so I want to use tan. I can write out tan 12, opposite over adjacent, that'll be H over 919. So solving for H equals 919. I'm going to keep the other decimals, the 0.25, times tan of 12. Okay, 195.39. I could say 0.4. Okay, so now we just basically found the height of the antenna. So we just leave a final statement. We can say, therefore, the height of the antenna is 195.4 meters. Okay, so that's it for our first example. I'll see you guys in the next video.